Hello students, myself Ashish Chawla. Today we discuss about the volume of cube and cuboid. First we take about cuboid. This is the shape of a cuboid having length L, breadth B and height h. The volume of cuboid is defined as area of base into height. As see here, the base of the cuboid is nothing but a rectangle. This is the base of a cuboid which is in the shape of a rectangle having length L and breadth B. So the area of base is L into B and its height is h. So the volume of the cuboid is L into B into h. So this is the formula for the volume of a cuboid. Now we discuss about the volume of cube. In cube we know that all the sides are of the same length. Cube is nothing but a cuboid in which length, breadth and height all are of the same dimension. Length is also of a units, breadth is also a unit and height is also of a unit. Length is equals to breadth is equals to height, let's say it be a. The side of a cube is a. So the volume is defined as we apply the same formula for the cuboid, that is L into B into H. Now we put in place of L I put A, in place of B I again put A, in place of H I put again A. So the volume of the cube is A into A into A, that is A cube. So this is the formula for the volume of cube and cuboid. Now we start with the problems. Now the first problem, the volume, find the volume cube having total surface area of 150 centimeter square. We have to find the volume of a cube whose total surface area is 150 centimeter square. So the solid that is given to us is cube and the side of the cube, that is A, which is, let it be A, and its surface area, total surface area is given to us, that is 6a square, which is equals to 150 centimeter square, that is given to us. Now at 6a square is equals to 150. Now solving this equation, we get a square is equals to 150 divided by 6, that is equals to 25. So as a square is equals to 25, so the value of a is 5, or we can say the side of a cube is of 5 centimeter. Now in this question we have to find the volume of the cube. We know that the volume of cube is defined as side cube, and side we already found, that is a equals to 5. So put a equals to 5 here, 5 cube, and we know that 5 cube is nothing but 125 centimeter cubic. So the volume of cube is 125 centimeter cubic. Now let's do one more problem. The area of adjacent faces of cuboid are x, y, z square unit. The area of the adjacent faces of a cuboid are x, y, z square unit. Then show that the volume is equals to under root of x into y into z. In this question, we have given a cuboid. Let's first draw the cuboid. Let's say this is a cuboid, and in the question it is given that the area of the adjacent faces are x, y, and z. So let's say the area of this face. Let's say the area of this face is x, and the area of this face is y, and the area of this face is z square units. Let us assume that the length of the cuboid is L, breadth of the cuboid is B, and the height of the cuboid is H. So here x is the area of this face. This face is nothing but a rectangle having length L and height H. So its area is x. We can say x is equals to L into H. L into H. Same way, this face having an area y square units, and this is in the shape of a rectangle having breadth b and height h. So its area is b into h. So the value of y is equals to b into h. Now the z is the area of this surface, and this is again in the form of a rectangle having length L and breadth b, having length L and breadth b. So z is equals to L into b. This is the equation number 1, equation number 2, this is equation number 3. Now when we are multiplying these three equations, 1 multiplied by 2 multiplied by 3, what we get? We getting x, y, z on the left hand side. And on the right hand side, what we observe, the length is coming 2 times, breadth is coming 2 times, and the height is coming 2 times. So all are get squared, L square, B square, or H square. So x, y, z is equals to L, B, H the whole square. It can be written like this. X, y, z is equals to L into B into H the whole square. So LBH is nothing but the volume of a cuboid, we know that. So XYZ is equals to V square. So volume of a cuboid is equals to, when you shift the square to the that side, so it gets under root. So V is equals to under root of XYZ. That is, the volume of a cuboid is under root of XYZ. That we have to prove it. So this is a one required result. Now we move to the next problem. How many bricks will be required? How many bricks will be required to construct a wall 13.5 meter long, 6 meter high, and 22.5 centimeter thick? If each brick measures 27 centimeter into 12.5 centimeter into 9 centimeter. So in this question we have to find how many bricks are required to construct a wall which is 13.5 meter long, 6 meter high, and 22.5 centimeter thick. If we construct the wall with the help of bricks, and the bricks dimensions are given to us, that is this one. Now with the help of this bricks you have to construct a wall. Let's draw the picture of it. That can be easily understood then. Let's say first of all we draw a wall. It is given that the wall is 13.5 meter long. This is the wall, 13.5 meter long, and it is 6 meter high. Let's say this is 6 meter high wall, and it is only 22.5 centimeter thick. See the unit carefully, that is 22.5 centimeter. So this is nothing but the length of a cuboid, this is nothing but the breadth of the cuboid, and this is nothing but the height of the cuboid. This is our wall. Now we have to create this wall with the help of a brick. and the dimension of the bricks are given to us. The dimensions of the bricks are given to us. Let's say this is a brick. So its dimension are given to us. Its length is 27 centimeter. That is our L. Its breadth is 12.5 centimeter and its height is 9 centimeter. Now with the help of this brick we have to construct this wall. So we have to find how many such bricks are required. Let me suppose that n bricks are required to construct this wall. So this wall is constructed with the help of these bricks and bricks. So their volumes must be equal. So the volume of this brick is nothing but L into B into H, and the volume of this wall is nothing but capital L into capital B into capital H. So we have to equate their volumes. So n times the volume of brick, that is small l small b h, is equals to capital L capital B capital H. So number of bricks is equals to capital L capital B capital H divided by small l small b small h. Now what we see here, the some units are in meter and some units are in centimeter. Now we have to convert all the units in, let's say, centimeter. So on the upside, that is length is 13.5 meter, so we have to convert into centimeter, so we have to multiply it by 100. Now breadth is in centimeter, so there is no need to convert. The height is 6 meter, so we have to multiply with 100 to convert it into centimeter. Now it is divided by the length, the volume of the brick. The volume of the brick, all the units of the bricks are in centimeter, so there is no need to convert it. So 27 into 12.5 into 9. Now we have to remove the decimals. Now first we remove this decimal. We have to put 1 0 at the downside. We remove this decimal. We have to put one more 0 at the downside, and the denominator side we remove this decimal. We have to put one more 0 on the upside. Now we cancel all the zeros. Now what we see here, this 225 and 125 are get cancelled with 25. Now we have to cancel it with 25. 225 divided by 25 we get 9. 125 divided by 25 we get 5. 9 and 9 are get cancelled, and 520 times. Now 135 and 27 are get cancelled with, let's say, 9. 9 3s are 27, and 135 it is cancelled with 1 5 15 times, and 15 is cancelled with 3 5 times. So what is our answer? So 5 into 20, that is 100. 100 into 6, that is 600. Now 600 in 10, that is 6000. So the number of bricks that is required to construct the wall is 6000. You do need 6000 bricks to construct the wall. So that is our answer.